Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over how to simplify powers of I. Don't forget, we have practice problems at the end of this presentation for you to try out so that you can demonstrate mastery of the contents of this presentation. All right, so to simplify powers of I, we're going to be writing a list of a pattern that can be used, and the pattern is cyclical in nature, okay? So let's consider the cyclical pattern for simplifying powers of I. All right, if you have this pattern mastered, then it will be very easy for you to simplify powers of I. Okay, so first of all, in the first row, we want to remember that I, just like every other non-zero number, raised to the 0th power is 1. Okay? And then I raised to the first power is just I. How do we know that? Well, it's based on the definition of square root of -1. All right? If you want to find the square root of -1, it simplifies. The simplest state is just I. All right? So keep that in mind. Now we have I to the second power. It's going to be -1. Well, how's that so? Well, if I is -1, then that follows that I square is going to be the square root of -1 raised to the second power. So the square root and the square cancels out, and then you get -1. Okay, so that's why I square is -1. And then I to the third power is going to be -I. How do we get that? Well, if you use the properties of exponents, I to the third power can be written as I times I square. You know, when you multiply powers with the same base, you add the exponents, right? So I to the third is the same thing as I times I square. We know that I reduces to I, and I square reduces to -1 based on this third row here. And then when you multiply these two together, you get -I. Okay? So what you just have to remember is that there are 4 rows for simplifying powers of I, okay? So this is row 1, row 2, row 3, row 4. Why are there only 4 rows? Well, because when you go to higher powers, you cycle back to the top. All right, so for example, after I to the third, the next is I to the fourth. Guess what? I to the fourth is exactly the same thing as I to the 0th power. Okay? And then I to the 5th power is basically I to the first power. It's just I. So let's take a look at just I to the 4th. You might wonder, why is I to the 4th 1? Let's just show you the work real quick. We know that I to the 4th can be written using the properties of exponents as I square times I square. What is I square? I square is -1 times -1, which is just 1. Right? Circles right back to the top. And then that's I to the 5th, I to the 6th, I to the 7th. Now guess where I to the 8th is going to go. You're going to cycle right back to the top. All right, so this would be I to the 8th, I to the 9th, I to the 10th, and I to the 11th power. So the pattern basically continues forever. All right, so the question is, how do you know which row to fall in order to determine what the power of I is? Because if you can find the row, it just reduces into one of these cases, either 1, I, -I, or -1. So it's one of these. Well, to determine what row you fall on, all you just have to do is you divide the power by 4. And then whatever the remainder is tells you the row. Okay? If you have remainder 0 after dividing by 4, you're going to be in the first row. Remainder 1 after dividing by 4, you'll be in the second row. Remainder 2 will put you in the third row. And remainder 3 will put you in the fourth row. Okay, so talking about the cyclical pattern of the powers of I, another way you can think of this is like a cycle. All right. So in this cycle, we have a unit cycle. So we have on the right side here, this is positive 1, positive 1. This is positive I, negative 1 in the opposite direction, and then negative I here. And then the powers of I just cycle across these 4 quadrants. Okay, so for the first cycle, this is I to the 0th power right here. And then over here is I to the first power, which is I. And then this is I to the second power, which is negative 1. And then this is I to the third power, which is negative I. All right, so we have this cycle going on, cyclical action going on here. So why do we say it's a cycle? Well, it's because when we finish the first cycle, you go from I to the 0, which is 1, to I to the 1, to I to negative 1, which is I squared, to negative I to the third, and then back to I to the 0th power. So that's the first cycle. Guess what? We can continue going on and on and on and on. So this is I to the third, right? So we've completed a full loop. So this is the same thing as what? I to the 4th, looping around, and then this is the same thing as I to the 5th, looping around. This is the same thing as I to the 6th power, and then this is I to the 7th, complete cycle. So you can keep spinning round and round and round. Let's do it again. So this is going to be I to the what? I to the 8th, 9, 10, 11, full cycle. All right. So that's why it's cyclical in nature. You're just looping around, just like a clock, right? What you're doing is modulo 4. Every time you go a multiple of 4, you circle right back to the beginning, right? Since there are 4 points here, that's why we're dividing by 4. And then when you divide by 4, you're taking out the complete rotations, and the remainder just tells you exactly what position you're going to end in. All right, so let's take a look at some examples. The task is to simplify the given powers of I. So if you have this chart that we have up here memorized, it's available on mathgotserved. You can download it from there under our formula collection. You're good to go. You don't need to know all the details that we talked about. All right. So all you just do, the steps for finding powers of I. Let's write it here. All you just do is you, 1, divide the power by 4. Okay, and then after upon division, you find the remainder. Find the remainder. And then you rewrite using the remainder as a power. Rewrite using remainder as a power. When you use remainder as a power, you're guaranteed to be between 0 and 3, okay? Because you can't go more than remainder 3 for multiples of 4. And then when you're done rewriting using the remainder as a power, then you use the chart. Use the chart to simplify. All right, so let's take a look at some examples using these steps. So number 1, let's say we have I to the 8th power. All right, we could just look at the answer here, but let's follow the steps and see how it works. So when you have I to the 8th power, this is what you're going to do. Step 1 is you're going to divide the power by 4, right? So we have I to the 8th power. So we're going to extract the power and divide it by 4. So what is 8 divided by 4? 8 divided by 4, 4 goes in 8 2 times. 2 times 4 is 8. Subtract that, and then you get 0. Bam. This is your remainder. Okay, per the steps here, step 3, we're to rewrite using the remainder as a power. So I to the 8th using our cyclical pattern is the same thing as what? As I to the 0. Okay, see the remainder becomes a power. Now if you go to the chart here, you can see that I to the 0 is equal to what? I to the 0 is equal to 1. All right, so there goes your answer. Now let's take a look at another example. Number 2, let's say you want to find I to the 49th power. How do we do that? To find I to the 49th power, following the steps, you divide the power by 4. Okay? 4 goes into 4, 1 times 4, 4. So bring down to 9. 4 goes into 9 twice. 2 times 4 is 8. Okay, when you subtract that, you get 1. There goes your remainder right there. So rewrite this using the remainder. So I to the 49th is the same thing as I to the first power. So when you go in cycles over and over again, I to the 49th is going to be right here. So I to the first power is just what? I to the first power is just I. Bam. There goes the answer to question number 2. All right, let's take a look at another example. Let's say you were to find I to the 27th power for number 3. I to the 27th power, we're going to follow the same steps. Okay, so I to the 27th, step 1, you just divide the power by 4. The goal is to find the remainder, okay? So how many times does 4 go into 27? 4 goes into 27 6 times. 6 times 4 is 24. When you subtract, you get 3, and that's your remainder. Bam. So I to the 27th in this cyclical pattern right here is the same thing as I to the 3rd. Now using the chart, what is I to the 3rd? I to the 3rd reduces to negative I. All right? Okay, let's take a look at one more example here. Okay, so let's look for the I to the 102nd power. All right, let's try that one. That's a big one. I to the 102. All right, so to do this, we're going to just follow the steps. It doesn't matter how big the number is. Sometimes you might have to use a calculator to figure out the remainder, right? So I to the 102. So following the steps, we're going to divide, right? Divide the power by 4. So 4 divided by 102. 4 goes into 10 2 times. 2 times 4 is 8. Subtract that, and you have 2. Bring down that 2. 22. 4 goes into 22 5 times. 5 times 4 is 20. Subtract. You get 2. That's your remainder right there. Bam. All right, so if we go to step 3, we're going to rewrite this as I to the 2nd power. All right, so what is I to the 2nd power? I to the 2nd power is, remember what it is? Go to your chart. If you've forgotten, it's negative 1. All right, so the simplified form of I square is negative 1. So something to keep in mind is that if your power is anything other than 1, you must simplify it. You cannot have a power other than 1 for your I. Okay? There you have it. Okay, let's have you do some practice problems. All right, so here are 6 problems that we'd like you to try out. 6 practice problems. So go ahead and pause this video presentation at this time. Try out these problems, and we'd like you to come back, hit on the playback button. We'll reveal what the correct answers are. Okay, let's do this. All right, welcome back. So here are the answers to the practice problems, problems 1 through 6. Go ahead and check your answers at this time. So how well did you do in these practice problems? Let us know what your score was in the comment section below. If you have any questions, specify it. We'll be more than glad to assist you. Thanks so much for taking the time to watch this presentation. Don't forget to help support our channel with your subscriptions, likes, and thumbs up. Tons of support resources can be found at mathgotserved.com. Do check it out. Thanks again for watching, and we'll see you in the next video. Goodbye.